Now, let us discuss order of convergence in Newton Raphson method. Okay, NRM is nothing but Newton Raphson method. Let us take f of x is equal to 0. Let us take f of x is equal to 0 is a function and x is equal to alpha be the root of the given function. Okay, then f of alpha is equal to 0 because f of x root is alpha, so f of alpha is equal to 0 and xn is equal to alpha plus en. Okay, so en is nothing but error and this alpha is root. Okay, so the root of the xn is the root plus error term. Okay, since we can also write xn minus 1 as xn minus 1 is equal to alpha plus en minus 1 and xn plus 1 is equal to alpha plus en plus 1. Okay, by NRM we have by Newton Raphson method we have that xn plus 1 is equal to xn minus f of xn by f dash of xn. Okay, then from this formula we need to derive the order of convergence. Okay, now I will this equation needs to substitute here and this will need to substitute here. So I will write as alpha plus en plus 1 is equal to alpha plus en minus f of alpha plus en by f of alpha plus en. Okay, so here f dash. Okay, then next here alpha and alpha gets cancelled and en plus 1 is equal to en minus, so I will expand this to Taylor series. I will expand these two to Taylor series. Okay, now we'll need to expand by Taylor series. And so f of alpha plus en can be written in Taylor series as f of alpha plus en into f dash of alpha plus e square n by 2 factorial into f double dash of alpha plus up to so on. Okay, by so f dash of alpha plus en Taylor series can be written as f dash of alpha plus en into f double dash of alpha plus e square n by 2 factorial into f triple dash of alpha plus up to so on. Okay, so next in next step here f of alpha is 0 in the above numerator. Here f of alpha is equal to 0 since alpha is the root, so f of alpha is equal to 0 and here en plus 1 is equal to en minus en plus en into f dash of alpha plus e square n by 2 factorial into f double dash of alpha plus up to so on by f dash of alpha plus en into f double dash of alpha plus so on. So if you are going to consider the higher order derivatives, finally it will become 0 since therefore do not consider higher order, do not consider higher order because it will become 0. So we need to consider up to two derivative. We need to consider up to two order derivative. So the next take f dash of alpha as common. Here en plus 1 is equal to en minus f dash of alpha into en plus e square n by 2 factorial into f double dash of alpha by f dash of alpha by f dash of alpha common. Here also in denominator also we need to take f dash of alpha as common. 1 plus en into f double dash of alpha by f dash of alpha. So I am not considering the higher derivatives because finally it will become 0. Okay, if you consider the higher order derivatives, finally it will become 0. Here f dash of alpha and f dash of alpha is cancelled, and here en plus 1 is equal to en minus en plus e square n by 2 factorial into f double dash of alpha by f dash of alpha into 1 plus en into f double dash of alpha by f dash of alpha, and here it will be minus 1. Okay, so I am taking this denominator to numerator, so it will become whole power minus 1, and then next I will expand this into binomial. I will expand this by using binomial. So here en plus 1 is equal to en minus en plus e square n by 2 factorial f double dash of alpha by f of alpha, and here 1 minus en into f double dash of alpha by f dash of alpha plus e square n into f double dash of alpha by f dash of alpha. For this it need to be whole square, and then next we need to proceed further. Now multiply these two and we will get, so we will get en plus 1 is equal to en minus, so if I multiply these two, so en into 1 en minus e square n into f double dash of alpha by f dash of alpha plus e cube n into f. So here I am not considering this. So if it is whole square means it will go to higher derivative, so and it will become 0. So I am not considering this, so I need to erase this. Okay, so because if we consider it also, we don't have any use because it will become 0 for the for the higher order derivatives. So the next I will multiply need to this, and e square n by 2 factorial into f double dash of alpha by f dash of alpha, and minus, so if I multiply with uh, this and this, it will also go to higher order derivatives because f double dash of alpha into f double dash of alpha, it will become f double dash of alpha whole square. So I no need to write this, so I can stop here. So the next is equal to en minus en plus e square n into f double dash of alpha by f dash of alpha plus e square n by 2 into f double dash of alpha by f dash of alpha. So here en will get cancelled. So now you need to take common as en square into f double dash of alpha by f dash of alpha into 1 minus 1 by 2, and it will become 1 by 2 into f double dash of alpha by f dash of alpha into e square n. So I can written it as, so en plus 1 is equal to k into e square n. So en plus 1 is equal to k into e square n, where k is equal to, k is equal to 1 by 2 into f double dash of alpha by f dash of alpha. Hence, that is order of convergence of NRM is equal to 2. Order of convergence of NRM is 2. Okay, 2 is the final answer. Okay, so finally we derived order of convergence. Order of convergence of NRM is 2. If you have any doubts, please comment below. Okay, thank you.